YouTube world, here we go. Diana Chaser air rifle in .22 caliber, stripped down and inspection with the goal of modification in mind. Tons of videos out there on the Crossman CO2 air rifle modifications, or all the Crossmans. The Crossman pumps, the CO2 conversions into PCP. Not much out there on the Diana Chaser. So today was strip down, clean out. It's pretty gummy inside from the oil, seal replacement, and a bit of a looky-loo to see how this thing works. I've actually had it down before. Beautifully simple system. Going to have a look and a think and scratch my head on some performance modifications. Now, I'm not an engineer, I'm not a mechanic. I think I'm of reasonable intelligence. But anyway, let's get into it. Let's have a look. I'm just going to express my thoughts. And of course, this is going to be open to public comments for anyone to tear me down, support me, or just comment or throw any information into the mix. Ill prepared here. I really should have put this thing back together in some kind of a fashion. But anyway, basic concept. I've made things very difficult for myself by putting stuff on this cardboard because everything rolls around. But I'm going to do what I can here. All right, basic concept. CO2 cartridge of about 1000 psi gets pushed in to the valve, okay? So let's get that out of the way. Here is the front side of the valve. See, I've got stuff rolling everywhere. Here's the front side of the valve. Now that doesn't have the original seal. My original seal is not very good. So when I reassemble this, I'm going to try, if I can focus, I'm going to try that O-ring in there. Anyway, that little nib in there punctures the CO2 cartridge and now fills your valve full of compressed air. When you cock the gun, the hammer gets pulled back, the hammer spring gets compressed, you pull the trigger, the sear holds that in place, holds it back, you pull the trigger removes the sear lets go, this is under compression, the hammer flies forward, the hammer hits the stem of the valve. Take this apart again, the valve then come out. The valve then comes forward. You can see the seat there. The valve comes forward. Compressed air escapes through the port, which is right there. The port butts up to the base of the rifle, so the air comes out through the valve, through the port, into the barrel behind the pellet, and the pellet goes flying. All right, so that's our concept. The little bit that is on YouTube about performance mods in these is one or two guys will talk about putting in a heavier hammer spring. I'm going to tell you why I don't like that idea. There's two things going on with this valve. So the hammer is compressed, then released. The hammer hits that stem, which opens the valve. So you've got force. Then you've got resistance. That spring, valve spring, sits on the valve, so it gets knocked forward. When the hammer spring is released, your valve spring is compressed, it lets air out, then the valve spring shuts the valve again. I'm going to put in a lighter valve spring, not a heavier hammer spring. Heavier hammer spring puts more load on the sear, the trigger, and I don't like that concept. We have force with this spring and resistance with this spring. I'm not going to increase the force, I'm going to lessen the resistance in an effort to open the valve easier and longer. In my mind, said I'm not claiming I've got this right. approximately 1,000 psi, pounds per square inch of pressure coming out of this guy. Once this is pierced in the cylinder, that's it. There is no valve. There's not really a valve on this front end. Not one that opens and closes anyway. When that CO2 cartridge, that power lid is pierced, you've constantly got 1,000 psi. Well, I shouldn't say. You've got 1,000 psi coming out of here. But what's the psi in here? If this cylinder is bigger, if the volume in here is bigger than there, the pressure is going to drop a little. Now, I have no idea, no way of measuring it, no idea what it is. But I'll make up some fictitious numbers to make my point clear. Let's just say that's 1,000 psi. But the air pressure in here in the valve is, we'll say the valve's bigger. Let's just say it drops to 700 psi. Because that's what the manufacturer wants. 700 psi coming up through the ports will push the pellet at X velocity. So let's say this is, for argument's sake, if this is 700 psi, I've got no idea what it is. But if you drill that out, if you take some meat out of the valve there, and you cut this thread in half to also take some meat out, you're going to increase the volume of the valve. Is that a good thing or not? You're going to have more air in the valve, but 1,000 psi there in a bigger space is going to be less psi here. So if I open up that valve, and again, I'm making these numbers up, but for argument's sake, if this is 1,000 psi, 700 psi, and I make the internal space bigger, am I dropping it to 500 psi? Am I creating more airspace but less pressure? Am I going to increase pellet velocity and power, or am I going to decrease it? I don't know. But at this stage, I don't think I'm going to start drilling and cutting and ripping and tearing into this guy. The way I'm thinking is it's all about, you've got two things. Air volume, which is how much air comes through the ports and through the barrel behind the pellet. That's all that counts. How much air comes behind the pellet to push the pellet, and how much pressure the air has behind the pellet. Now, there is a sweet spot with this stuff. You can over-exhaust it. You can have too much. You can have too much air that's going to be wasted because there's resistance to that pellet when it's spinning in the barrel. Okay, so you can go past your sweet spot and have too much air. And you can open your ports up too much, which will drop your pressure. Okay, so if you think of a garden hose, if you have a clear open garden hose at the end, you're going to have a lot of volume, a lot of water, but less pressure. You put a nozzle on the end and close that nozzle almost all the way off, you're going to have more pressure, but you're going to have less volume. So when you need to hose the driveway off at home, you adjust that nozzle for that sweet spot, volume of water at the maximum pressure that hose nozzle can deliver. This is what this is what all of us are trying to do. That's the goal. Volume and pressure to find that sweet spot. Now I can open up these ports a little, approximately 20%. Is that going to hurt performance? Is it going to increase performance? I don't know yet. But this is everything that needs to be considered. Before you start drilling, before you start cutting, sure, you can buy new parts, but do we really want to do that? Do we want to screw it up to spend money on parts that we screwed up? So it all comes down to, as I said, air volume, the right amount, the maximum without going over the edge, the maximum amount of air volume. Well, your volume is all on this valve. Your volume comes from how long this valve is open. That controls your volume, that only. All right? The longer this valve is open, the more air you're going to get. It's that simple. So I'm going to go for a lighter spring to get more volume. I'm going to go for a lighter spring here to hopefully have this valve open easier and sooner and longer. If it opens easier, sooner and longer, I'm going to have more air coming through the standard ports. So that's where I'm going to start. Next thing is pressure. If I can understand, and the only way I can measure this, is this guy in the 0.22, I get 33, 35 full power shots. We'll call it 35. I get 35 full power shots before performance fades. Let's call it 30, easier math. If I put in a lighter spring and get this thing back together, and I'll get 25 full power shots instead of 30, well, then I know I've increased my air volume. I know it's worked. I don't have a chronograph. So if I'm getting 25 full power shots instead of 30 or 35 now, I can say to myself, yeah, this cartridge is now dying out at 25 shots instead of 30 shots. So therefore, I've increased the amount of air that's coming out with each shot. Once I know that, then I can decide whether I want to play with pressure. Then I can decide whether I want to modify the valve or open the ports. All right, so very low tech, very low. That's what I might call this this video: low tech, low IQ engineering. So yeah, anyway, that's where I am. I'm about to go to the hardware store. Wish me luck. I'm going to endeavor to find a lighter spring, and we'll go from there. So obviously, yeah, there's going to be more videos. Thanks for watching.